All right, now we're going to start the second part of Lesson 8, which is the product rule. So this is trying to do derivatives of things that are more complicated. So if I want to take the derivative of this f of x, then I could go in and do the algebra and say that f of x equals x to the 6th plus 6x to the 5th. And then say f prime of x equals 6x to the 5th plus 30x to the 4th. Okay, and so this is my derivative. Now, if I want a simplified derivative, that's all fine and good. But when I get to the next one, so when I get to finding the derivative of the second question of part B, that gets a lot more complicated because to multiply this out, I have to do the derivative, I have to do the distributive property twice, right? I have to go and I have to say 3x squared times x squared plus 4x minus 2x times x squared plus 4x. And then I have to go, well, g of x is 3x to the 4th plus 12x cubed minus 2x cubed plus 8x squared. Now I have to simplify it, so gx equals 3x to the 4th plus 10x cubed plus 8x squared. And if I'm not really good at multiplying these things out, I have a higher chance of making a mistake. And now I have to take the derivative. So now I have to go and find that g prime of x equals 12x cubed plus 30x squared plus 16x. Okay, so now I have to take the derivative. So it gets more complicated. And what if it were a trinomial times a binomial? Or 4 terms? Or 5 terms? So it starts to get more and more complicated. So there's this rule called the product rule. And what the product rule says is that if I have two functions that are multiplied together, so if I have f times g prime, then it is the derivative of the first times the second function plus the first function times the derivative of the second function. Okay? So for this last one, okay, so I'm going to go back up here, and I'm going to write down here that g of x is x squared plus 4x times 3x squared minus 2x. So I'm going to write this back down here so that I have enough room down here to write down. So if I were now to use the product rule on this, then what I do is I say let f equal x squared plus 4x. Then f prime is going to simply be 2x plus 4. And let g equal I was going ahead and taking the derivative. Let's g be 3x squared minus 2x, and let g prime equal 6x minus 2. Then you use the product rule and find g prime of x equal to the first one, the derivative of the first, which is 2x plus 4, times the second function, 3x squared minus 2x, plus the first function, x squared plus 4x, times the derivative of the second. Now, unless I tell you to simplify it, that is a perfectly good answer to me. Okay? Now, I want you to also realize that if you're having trouble remembering whether to add or subtract once we enter into the quotient rule, then if you go back to the little pyramid Remember that I said that you have to keep your multiplication over addition and your division over subtraction. Well, if I'm doing the product, which is multiplication, then it's over addition. So if I have a product and I'm multiplying, then I add. So product means add. Quotient or division means subtract. Okay? So now let's get on to some of these. Now, let me say this. If it says simplify your answer, to me, the easiest way to do that would be on this one, and on the second one, would be to go ahead and distribute and simplify it before you start. And guess what? That's perfectly fine with me. Okay? You do not have to use the product rule unless you just want to. Now, for these examples, I'm going to show you method 1 where you simplify first, method 2 where you simplify second. Okay, so method 1 is where you have h of x and you change it to be 9x plus 2x squared and then take the derivative. Okay, and method 2 where you use the product rule. All right, where f is x and f prime is 1 and g is 9 plus 2x and g prime is 2. So then h prime of x equals 1 times 9 plus 2x plus x times 2. So then h prime of x, you just simplify this. So that's 9 plus 2x plus 2x. So that's 9 plus 4x. Okay? And those are the two methods. And you should get the same answer with both methods. All right, so now let's go on to the next answer. And again, I'm going to do both methods. So method 1, you get y equals 9x cubed minus x to the 5th. So y prime equals 27x squared minus 5x to the 4th. And over here, you're going to use f g prime equals f prime g plus f g prime, where f equals x cubed, f prime equals 3x squared, g equals 9 minus x squared, so g prime equals minus 2x squared. So then y prime equals 3x squared times 9 minus x squared plus x cubed times minus 2x squared. Squared minus 3x to the 4th Why am I not getting what I should be? Oh, that should be x. That should be x. So then this should be minus 2x to the 4th. So then y prime equals 27x squared minus 5x to the 4th. Okay. Little mistake, but I realized I should get the same thing. All right, so again, I have two questions. I have two parts to this one. Okay. So I have method 1, where I have y equals x to the 6th x to the 1/2. So 6 plus 1/2 equals 12 halves plus 1/2 equals 13 halves. So I get y, so equals x to the 13 halves. So then dy dx equals 13 halves x, and then I have 13 halves minus 2 over 2 equals 11 halves to the 11 halves. So now over here I have fg prime equals f prime g plus fg prime. F equals x to the 6th, so f prime equals 6x to the 5th. G equals x to the 1/2, so g prime equals 1/2 x to the negative 1/2. So then dy dx equals 6x to the 5th, x to the 1/2, plus x to the 6th times 1/2 x to the negative 1/2. So what I have to add over here is I have to have 5 plus 1/2, so that's 10 halves plus 1/2 is 11 halves, and I have to have 6 minus 1/2, so that's 12 halves minus 1/2 is 11 halves. All right, so dy dx equals 6x to the 11 halves plus 1/2 x to the 11 halves. All right, and so what is 6 plus 1/2? So that's 12 halves plus 1/2, so that's 13 halves. So I get dy dx equals 13 halves x to the 11 halves. So I got the same answer both places. But this way, but using the product rule was a lot more fractions. Okay? So now, these, from here on out, we don't simplify. Yay! All right, so the first one, we're going to use the product rule. Notice that every time I use the product rule, I write it. The reason being, I'm trying to learn it. That way, when it comes to the test, I know it. F equals x to the 0.4 minus 2x minus 3. So f prime equals 0.4x to the negative 0.6 minus 2. And g equals x to the minus 1 plus x to the minus 2. So g prime equals minus x to the minus 2 minus 2x to the minus 3. So dy dx equals, this is f prime, equals 0.4x to the negative 0.6 minus 2 times g, x to the negative 1 plus x to the negative 2 plus f, x to the 0.4 minus 2x minus 3 times g prime minus x to the minus 2 minus 2x to the minus 3. And that, ladies and gentlemen, is your answer. Okay? Okay, let's go on. Okay, for the next one, we're going to find the derivative and then we're going to plug in the number. Okay? So, first, we're going to use the product rule. So, FG prime, so that's F prime G plus FG prime. So, F is x cubed plus 4x. So, F prime is 3x squared plus 4. And G is x squared minus x. So, G prime is 2x minus 1. So then when I put it up here, I'm going to have 3x squared plus 4 times x squared minus x plus x cubed plus 4x times 2x minus 1. Now I'm going to put the big bracket around it, and I'm going to put the x equals 2 at the bottom because I'm evaluating this thing at 2. Now this all right here is my sidebar. It's all my work to the side. Now I'm going to put 2 into this. So that's going to give me parentheses 3 times 2 squared plus 4 times 2 squared minus 2 plus 2 cubed plus 4 times 2 times 2 minus 1 equals 3 times 4 plus 4 times 4 minus 2 plus 8 minus 8 times 4 minus 1. Sorry. Dog's going nuts. Okay. I changed that to a minus sign and it should be a plus. Okay, so this is 12 plus 4. 4 minus 2 is 2, plus 16, and that should be 3. So I have 16 times 2 plus 16 times 3. So this equals 16 times 2 plus 3. So that equals 16 times 5, which is 80. What I did from here to the next row is I factor 16 out. And I did that just to make it a little, I realize you have calculators, but what if you're standing in front of a classroom and you need to factor it out real quick? Or what if you're in a business meeting, or you're trying to get a grant, or you're in an art or something and you need to calculate something real quickly? It's really hard to think about what 16 times 2 is and 16 times 3 is. But if you factor out that 16, and then you add 2 and 3, 2 and 3 is 5. Then you can calculate real quickly that 16 times 5 is 30, because 16 times 5 is 80, because 6 times 5 is 30. 5 plus 3 is 8, so that 16 times 5 is 80. Okay, so try to think of ways to do that, because you're going to be teaching math, or you're going to be using math, and so you want to try to make things simple for you, or easier for you. Okay? So that's how you would plug that in and evaluate that. Now let's look at how to find the tangent line. All right? The first thing we need to do is we need to find our point. So that is find f of 1. So that equals 1 to the 4th plus 1 times 1 squared plus 1. So that's 1 plus 1 times 1 plus 1. So that's equal to 2 times 2 is 4. So we have the point 1, 4. Second, we need to find the derivative. To find the derivative, we're going to use the product rule. So that's f prime, that's product rule is fg prime So that's f prime g plus f g prime, where f equals x to the fourth plus 1, so f prime equals 4x cubed, and g equals x squared plus x, so g prime equals 2x plus 1. So f prime of x equals 4x cubed times x squared plus x plus x to the fourth plus 1 times 2x plus 1. So third, we need to find our slope, which is f prime of 1. So that is 4 times 1 cubed times 1 plus 1, or that's 1 squared, plus 1 to the fourth plus 1 times 2 plus 1. So what we get is 4 times 2 plus 2 times 3. So that's 8 plus 5 is 13. So 4, we have m equals 13. We have the point 14, and we have the line y equals mx plus b. So then we have 4 equals 13 times 1 plus b. So 4 equals 13 plus b. So negative 9 equals b. So then our tangent line, did I make a mistake? I did. I said 3 times 2 is 3 times, this should be 14. So this should be 14. So this should be 14. 14. So this should be minus 10. So our tangent line is y equals 14x minus 10. Notice, I want you to notice some things. I did not simplify my derivative to plug it in. I don't have to. There is no need. Unless the problem specifically tells you to simplify, please do not simplify. All right? Also, please realize that I'm not going to give you atrocious numbers and to take your time. I was rushing through this